Here we have example 11.3 from the book, and in the book the reorder point is calculated for a given cycle service level. Here we will extend our calculations to calculate the reorder point for a given fill rate, which is the same as the cycle service level. It is equal to 95%. We have the average and standard deviation of lead time in days equal to 9 and 2 respectively. We also have the demand per day, average demand per day equal to 16, and standard deviation of demand per day equal to 3. Based on these numbers, I can calculate the average and standard deviation of demand during lead time. And the point is that here, as you can see, the lead time is in days, the demand is given in per day, so I can use the numbers as they are presented here to do my calculations. Otherwise, if the time units were not consistent, I needed to do some more calculations to make the time units consistent. I'll start with the average demand during lead time. So it is d bar L bar, so it is average demand during lead time, average demand per time unit here per day, multiplied by the average lead time, so 144. And for the standard deviation of demand during lead time, I will use the formula here. So it is square root of L bar multiplied by sigma d to the power of 2 plus d bar to the power of 2 multiplied by sigma L to the power of 2. So 33.24. It is the standard deviation of demand during lead time. Now I can do the calculations to find the reorder point, but to get to that point I need to take some steps. I need to fill in some other cells and then conclude the reorder point. First, I need to calculate the safety factor, and the safety factor is the corresponding z value of a standard normal distribution to the service level, or given service level. Just to repeat again, it is the z-score of a standard normal distribution corresponding to the given service level. So I have the service value. I need to calculate the z-score. I will use the inverse of the standard normal distribution. So it is norm S in, and then I will feed the service level. So normal distribution, standard, and then inverse, right? It is a well-defined function in Excel. So now I have the safety factor. I can calculate the safety stock. Safety stock is safety factor multiplied by the standard deviation of demand during lead time. So I will get this number, and then to calculate the reorder point I need to add the average demand during lead time and the safety stock. So 198.7, and of course I will round it up to the next integer value. So 199 is a reorder point that will ensure meeting a cycle service level equal to 95%. Now let's do the calculations for a given fill rate. For these calculations, I need to have the Q, which I will assume is equal to 100 in this case. Okay, first, again, to calculate reorder point, I need to take some steps, and I will start with calculating Gn of z, the unit loss function. So Gn is equal to Q multiplied by 1 minus Fr divided by sigma dl. It is not anything new, it is just the same equation that we saw in our slides. Just here we have solved this equation for Gn because we have sigma dl, we have Q, we have Fr, so we can solve this equation for Gn, which will give us this equation, this new equation. So after that I will find the safety factor, that having the safety factor or the z value, I can do the calculations to find the reorder point. First, let's start with Gn of z, which is equal to Q multiplied by 1 minus fill rate divided by standard deviation of demand during lead time, which is 0.150. Okay, now I have Gn of z, but I don't know which z value corresponds to this value, right? To find the corresponding z value, I need to use the other Excel template, Excel sheet that is provided to you, which will do the calculations for us. Here in this cell, I will explain how it works first, and then explain how we will use it to solve our problem. Here in this cell we have replicated, we have put the formula for the unit loss function. If you remember, it was the probability distributed for a given z value z, then Gn of z was the probability density function of a standard normal distribution minus z times 1 minus the cumulative distribution function evaluated at point z. So here I assume that z is determined at this point and in this cell, and then I can write down my formula or replicate or the formula that I had like this. So it is the normal distribution for z, for evaluated at point z, with mean 0, standard deviation 1, and the last argument equal to 0, which means that it is not a cumulative distribution function, but it is a probability density function. And then it is minus this phi, this is the lowercase of phi, minus z multiplied by 1 minus, here we have the capital phi or phi, and it is capital because for the last argument we have 1, which indicates that it is a cumulative distribution function. So here I have simply this formula, this equation, right? And if I change the values for z, I can see that the computed g and z's will change. Then I have a target value. Target value is the value that I have calculated in my example. It is 0.15 and so on. I will put this target value here. I want to change these z values, right? To find a z value that will give me this Gn of z, this computed Gn of z equal to the target Gn of z. But I will not do it by hand, but I will let Excel do the calculations for me. So next I will explain how it is done in Excel. But before that, let's see what we have here. It is simply the difference between the target Gn and computed Gn. And then we have multiplied by 1000 to increase the accuracy of our calculations. If I find a z value that will give me a computed Gn equal to target Gn, then the difference will be equal to 0 or close to 0. So I want this value to be close to 0 as much as possible. To find the corresponding z, I need to go to the data, to the what if analysis in the forecast panel, to the goal seek, and then I will have this window popped up on the screen. So, as I mentioned, I want this cell to reach to 0, approach to 0 by changing z. So it will change what after pressing OK here, Excel will change z values here, compute the gn of z, compare it with the target gn of z, and see how big is the distance between these two values. And if it is sufficiently close to each other, or in other words, if this difference is sufficiently close to the 0, then it will stop the calculations and return the z value. Okay, I press OK, and it does the calculation, and it returns a z equal to 0.669 and so on. Okay, this is what I need from here. So let's do it like this. Okay, it's easier to work with these numbers. Okay, so I first calculated gn of z and then found the corresponding z. Next step is easy. I need to calculate the safety stock, which is the safety factor multiplied by standard deviation of demand during lead time. And then for the reorder point, I need to add the average demand during lead time and the safety stock, which is in cell B29. So it is 166.254, and to make sure that the fill rate is satisfied, I will round up this number to the closest integer value. So 167. That is the solution to our problem.